So as you can see, actually this also makes see whenever you get some results, also try to see if the results make sense or not. So if it is 0.2 here and it is increasing up to 0.255 here, it's increasing again to 0.585, still it is less than our peak value, and then after 2 meter mark it will decrease. So from 0.64 it's decreasing to 0.61, and then further decreasing and further decreasing. So yes, our values are making sense. So let us now calculate. So where is our formula? Uh, Schmertzmann formula. Let's recapitulate then. Okay. So after we have calculated the I's for each case, what we need to do is we need to calculate. Okay. So we need to calculate the C1, the C2, the Q effective we know, and this entity Q epsilon, uh, the strain influence factor multiplied by the depth of that strata divided by E. So let us first copy our E's. We have calculated our E's here, I think, yes. So this is for the first layer, this is for the second layer, and for the third layer. Let us take it here. Okay. But now this is from 2, 2.5. Uh, this is from 0.5. This is from 0 to 0.5. So this will come here. And this is from 0.5 to 2.5. So this will be E1. This also will be E1. Give me a moment. Okay. So if you look at the stratas here, if you look at the stratas here, this is one strata, one Z value we are getting in one strata, two Z values we are getting in the second strata, and two Z values we are getting in the third strata. Let us assume that instead of 2.5 to 5, the QC is for 2.5 to 8. Let us assume that for now. Okay, so this is E. Why there is this discrepancy? Because as I mentioned earlier, that I was referring to BM Das. I was referring to BM Das. So I was referring to BM Das, and in BM Das, this question, uh, not exactly in BM Das, the method I was referring to, this the height was extending up to only 4 times B, only 2 times B. Here it is extending up to 4B. That is why we are getting at 8 meters. And according to that question was given for up to 2 times B, which is only 4 meter. So the strata was inside the diagram. But for this, let us take Q, QU same for this strata. Okay. So this is E, and let us take the height of each layer. This will be 0.5, then this will be 1.5, this will be 1.25, no, sorry, this will be 2.5, then again, okay, there is an extra layer here, that is zero point 0.5, that we separated this 2.5 into 2 meter and excuse me, one we separated this layer into two layers of 1.5 and zero point 0.5, and then we have a 2.5 and we have a 3 meter layer. Okay, so this is the H, this is the E. Okay, so what we need to calculate is, let me actually clear the slide a little bit. Okay, so let's write the Schwarzman formula here so that it gets easier. So our delta will be equivalent to C1, C2, Q effective, summation of I, H over EI, where our C1 equals 1 minus 0.5 Qs by Q effective, and C2 equals 1 plus 0.2 log of 10t. So, excuse me, Qf is the foundation pressure, Qs is the surcharge pressure, effective surcharge pressure at the base level. Is it effective? Okay, so at base level it will be gamma df, 18 into 1.5, 63. So calculating C1 we will get equal to, let's check this. So our QEF is actually QF minus gamma df. we calculated in the previous slide. I think it was coming out to be 123 or something. Okay, the 63 was gamma df plus b. It's not gamma df. Just thinking what's happening. Let's just write the formula. C1 will be 1 minus 0.5, 18 into 1.5, 150 minus 18 into 1.5. This comes out to be 0.89, and C2 equals 1 plus 0.2 log of 10t, and in the question our t is given, t is 10 years. So time here is in years in this formula. Because this is an empirical formula, it is always necessary to know in which units the time in the empirical formula is given. Obviously, in a formula that is derived, you can change the units based on if you know the units for everything. But in empirical formula, especially, it is necessary to fill in based on what units have been given for this. So C2 is 1.4. Let us fill the IH by E here. 0.5 into 0.25545620. Let us keep a common 10 to power minus 5 here. So this comes out to be 2.268. This is 9.369. 3.274. 14.1 it's coming out to be. 2.5 into 0.453 over 8028. This is 14, no, 0.14. This will be 0.141. 14.1141, and this will be 5.979. Let me check for the last one. 2.5 into 0.453 over 8028. Yes, 14. 0.1 into 10 to the power minus 5. So the sum comes out to be 2.268 plus 9.369 plus 3.274 plus 14.141 plus 5.979. 35. Let me write the sum here. Summation of I H over E is 35.031 into 10 to the power minus 5. Okay, so based on this, let us calculate the delta. Okay, so the value comes out to be 0.057 meter, or so the answer is 57 millimeter. Okay, so that is for this question. I was going to do another question, but I believe it is better if we do it in the next session. So here the answer is, how much was it? 57 mm. If there are some, I know there is a lot of breakage in the videos for this session. I apologize for that. But if there is a question, if there is somewhere that the calculations are not correct, or somewhere that you have a doubt, please ask me in the discussion forum. Thank you very much.